All right, so this week we're doing a lot of things with polynomials, and one of the things that we're covering is polynomial long division, which is usually a struggle for a lot of people. Long division in general, if we're just going to dividing with numbers, people hate. And now you add variables, and people hate it even more. So I thought this would be a good topic to go through, so that way you get an idea of how it works. And as long as you follow the rules and you follow the procedure, you should be fine. So why do we even do this? This is a good question, especially because there is a shortcut method called synthetic division. So for one thing, synthetic division doesn't work in every situation, so you have to sometimes go back to this longer method. But we do long division of polynomials versus with either with this long method or with synthetic division. We divide them because it allows us to take a rational expression, fraction, it's pretty complicated, and simplify it if it can't be factored. So sometimes we can't simplify by factoring, so we have to find another way to get it easier to work with, and so we divide it out. It's something that we use to find oblique asymptotes, which is something that you will see in the next couple weeks when we look at graphing rational functions. And it's a useful skill in calculus to make integration and differentiation easier. So if you don't have to take calculus, then you don't have to worry about using this too much in your real life. But those who do have to go on to take calculus, this is going to be a handy skill, so they're going to really want to pay attention to this. And for whatever reason, when I learned this stuff in high school, I didn't really like math, but for whatever reason, I really loved doing long division of polynomials. And when I was bored, back before we had cell phones and everything, and I'd be like at the doctor's with nothing to do and waiting to get in, I would make up long division problems for me to do just because I thought it was fun. Didn't really like anything else about math, but I did enjoy this. So I'm going to just start with a review of how to do it with numbers so that you can see the process, and then you can see that it's actually very similar when we do it with variables. So first one on the left here, I have 3,250 divided by 5. So I'm going to set up my division. So inside the long division, which is sort of like a square root, but not, it doesn't have the v part of it. And then I'm divided by 5, so that goes on the outside. So when we're doing long division, we are basically saying, okay, how many times does 5, the outside number, go into your first digit, which is 3? So 5 doesn't divide into 3. So then you move on and you look at, well, how many times does it go into the first 2 digits? So 5 times 6 gets me 30. 5 times 7 will get me that. So it goes into it 6 times. So I put that number on top, and then I do 5 times 6, which is 30. So that gets written underneath, and then I subtract. So 32 minus 30 is 2, and then I bring down the next digit. And then I say, okay, how many times does 5 go into 25? So we look at what we got after we subtracted, and then brought down the next digit. So 5 goes into 25 5 times. So I write that on top. 5 times 5 is 25. So I write underneath, subtract. I get 0, and then I do have to drop down that other 0. 5 goes into 0 0 times. So you have to make sure you keep going until you've used all of your digits. 5 times 0 is 0. And you keep going until you basically get a remainder, where you can't go any further, or there's no remainder. So in this case, there's no remainder, and the answer is 650. So let's do it again, just so you can get practice with the steps. With the one on the right, which is 2,273 divided by 4. And this one's going to have a remainder, so you can get an idea of what it looks like with and without a remainder. So again, I first say how many times does 4 go into 2, but I can't divide that, it doesn't go into 2, so then I look at 22. So 4 times 5 will get me 20, so that's the closest that I can get to there. So 4 times 5 is 20, so I subtract 20. 22 minus is 2, and then I bring down the 7. So then how many times does 4 go into 27? So 4 times, that's 32. 4 times 6 is 24. So I do 27 minus 24, which gives me 3 left over, and then I take that 3 and I bring it over. So now I'm looking at 33. So 4 times 8 is 32. So I can subtract 32, and I'm left with 1 left over, and that is our remainder, because I don't have any more numbers that I can drop down. So if there's no more to drop down, that is your remainder. And that is what gives you a fraction. So 568 is the whole part, and then we have 1/4 left over. So that's how long division works when you have numbers. You either get 0 at the end, which means there's no remainder, or you get a remainder, and that becomes a fraction. So when we do long division, when we have variables, the process is going to be very similar. And most of the time, you're going to end up with the remainder. So most of the time, you have a portion with a fraction. So it's going to look more like the one on the right versus the one on the left. So what I did is I tried to write down all of the steps so that you have something to follow. And this may look confusing at first, but if you maybe print this out when you do your homework and have it next to you as you go through the examples, that might help you kind of see what's going on. So we have 2 things that we're dividing. The thing before the division symbol is called the dividend. The part that's after the division symbol is called the divisor. Sometimes you will see it also written as a fraction. So if it's in fraction form, the dividend is on top, the divisor is on the bottom. So if you see a fraction with variables, that is also meaning doing division. It's just shown differently. Basically, we're always looking at the first term of your polynomials that you're dividing here. So we're always basically looking at the first term, and then once you get done with the first term, you move on to the next term. So it's kind of like here, we were first looking at the first number, then we moved on to the second number, then we keep moving further and further to the right. So it's the same process when we divide with polynomials. But it's almost easier with polynomials because if you do exactly what I've written here, then you don't necessarily really have to do any thinking. And what's really nice is this little rhyme to kind of help you out, because they're going to end up getting like negative signs, and then you're subtracting a negative. So the easiest thing is we're going to basically change every sign. And it will make sense when I go through this. But I tried to write this out so that you can follow it as much as possible, and you can kind of see what the process is that we're doing. And then at the very end, once you get your answer, you write it as something without any fractions, and then you're going to have your fraction at the end. So the part without the fractions is called the quotient, and then the fraction forms the remainder. So I'm going to just show this in action here. And the way that I do these problems is I have 2 pieces of work. I basically have like a halfway point. And on the left is my division work, so I can label it. And then on the right is the side work that I have to do. So I kind of work two things at once so it doesn't get too confusing. So we're going to set up the division like we do with numbers. So what's in front is going to be inside the division symbol. And then what's after the division symbol goes outside. And we're going to be focusing on the first terms, basically. So we're going to just look at the 3x on the outside and then the 12x squared that's on the inside. And that's what we're going to look at. So when we did division with a number, you'd ask, how many times does the outside go into the inside? Well, that doesn't really make sense if you look at that with variables. So what we do instead is we take the inside term, let me make sure that I'm in my pen mode. So the inside, and I'm just going to look at the 12x squared, and we write it over the outside part that we're worried about, the 3x. And then you simplify. So you actually do that division. So 12 divided by 3 is 4. And then x squared over x leaves me with an x when you simplify. So that x on the bottom has an exponent of 1. You subtract top minus bottom, 2 minus 1, you get 1 left over. That is what goes on top of our first term. So that 4x is going to go above the 12x squared. Now going back to long division, we wrote the number on top and then we would multiply it by what's in front so that we can subtract it. So like in the first example, I do 6 times 5 and that's why I have 30 written underneath. So we're going to do the same thing here. I'm going to take that 4x and multiply it, but I'm going to multiply it by the entire thing outside, 3x plus 4. So we're going to distribute 4x times 3x is 12x squared. Then 4x times 4 is 16x. And we write that underneath our dividend. So I wrote 12x squared plus 16x, and I want to make sure I line up the like terms. So now we subtract these, and the way we do that once we have variables is we have the rhyme. Draw the line, change the signs, and I do that by circling so that I remember that I changed the sign. So everything positive becomes negative, and then you combine them. So 12x minus 12x is 0, or 12x squared minus 12x squared is 0. So that cancels out. 10x minus 16x gives me negative 6x. And then I drop down the next part. Just like in long division, let me go back. We drew the arrow, we dropped down. So in that first example, after we subtracted 32 minus 30, we got 2, we dropped down the next part. So same thing here, we did our subtraction, we dropped down the next part. Now we're going to focus on the first term again. So now instead of looking at the 12x squared, I'm going to look at that minus 6x. And I'm going to repeat the same process here. So maybe I will do this one in yellow. I'm going to take negative 6x and I'm going to write it over 3x. That same thing. So we're always taking the first term on the outside. So that's going to be, you're going to see a pattern here. And we divide this out. Negative 6 divided by 3 is negative 2, and the x's cancel. So that is what gets written up on top. So I write negative 2 above that second column. Then I take that negative 2 and I'm going to multiply it by the 3x plus 4. So I need to distribute negative 2 times 3x as negative 6x. And then negative 2 times 4 is negative 8. And that is what gets written underneath, negative 6x minus 8. So we draw the line. We change the sign. So all of these negatives become positives. Again, I circle them just to remind me that I did that. And then you combine them. So negative 6x plus 6x is 0. 3 plus 8 is 11. And now we have, this is going to be our remainder. So 11 is our remainder because we look at the degree. So the 3x plus 4 has a degree of 1. There's 1x. The 11 has 0 x's. So if you have fewer left over than you started with, so like 11 has 0, would be dividing by something with 1, that tells you you're going to have a remainder. So you keep going until you're not going to have any more x's or whatever to get rid of. So that is your remainder. So that's when you can then write your answer. So what's on top of the division symbol is our whole part, 4x minus 2. And then the remainder forms a fraction. 11 was a remainder, and then we put it over 3x plus 4. So it's very similar to how we divided with the example on the right. We had our whole part, and then we had a remainder, and that created a fraction. The process is essentially the same. It just looks very different because now we're dealing with variables. But in a way, it's almost easier because there's less thinking. When you're doing long division with whole numbers, you have to think, okay, how many times can I multiply this in order to divide it out? And when you have bigger numbers, it's harder. But here, we're just doing strictly division. It's almost less thinking. You don't really need to know your multiplication tables like you do with long division with numbers. All you have to do is be able to use a calculator and do the division. So I think it's actually easier. Are there any questions on this example? Okay. So, second example here. We have 2x cubed minus 7x squared minus 65 divided by x minus 5. So again, I'm going to just separate this out into two different parts. I'm going to take the first part. Now here's where we have to do a little thinking. I have 2x cubed minus 7x squared, and we want to make sure that we have a spot for each value of x. Now, I don't have an x there, so we are going to just write plus 0x to kind of have a placeholder. You don't really have to worry about placeholders when you're just dealing with numbers, but when you have variables, you need to worry about placeholders so that you have every x going down, because sometimes you're going to need a place to put it. And then I've got my x minus 5 on the outside. So let me just make sure that plus looks clean. So I have to put a placeholder. So if I have an x cubed, you're going to have 4 terms. So whatever your highest exponent is, you need to have one more term than that. So if my exponent was 7, I would need 8 things written down. So I'm going to again look at the first term of each of these, the 2x cubed and x. So 2x cubed, and I write it over x, and then I simplify. So I'm going to have a 2, and then I basically canceled out one of the x, and I'm left with x squared. So I'm going to write 2x squared up on top. Then I'm going to take that 2x squared and multiply it by the x minus 5. So I need to distribute 2x squared times x is 2x cubed. And then 2x squared times a negative 5 gives me negative 10x squared. And then I'm going to write that underneath. 2x cubed minus 10x squared. And then we draw our line, we change the signs. So anything negative becomes positive, positive becomes negative, and then we combine them. So the 2x cubed minus 2x cubed, that cancels, that's 0. We have a negative 7x squared plus 10x squared. That leaves me with 3x squared. And then I do need to drop down my 0x. So now I'm going to repeat the process using the 3x squared instead. So I'm going to have 3x squared over x. So all that does is remove one of the x's, and that leaves me with 3x. So I'm going to put plus 3x above the second column. Then you take your 3x and you multiply it by x minus 5. So 3x times x is 3x squared. 3x times negative 5 gives me a negative 15x. So I'm going to write that underneath. And this is why we had to have that placeholder, because we need something to add the 15x to. So I'm going to draw my line, change the signs, and then combine. 3x squared minus 3x squared is 0. 0x plus 15x is 15x. And then I need to drop down my minus 65. So I can keep going because I still have an x present here. And this time I'm going to do it again with my 15x. So I'm going to take that 15x and divide it by x, which leaves me with just 15. So I'm going to have plus 15. Then I take that 15 and I multiply it by x minus 5. So 15 times x is 15x. 15 times negative 5, I need a calculator for. That gives me negative 75. So I write that underneath, 15x minus 75. Draw my line, I change my signs, and then you combine. 15x minus 15x is 0. Negative 65 plus 75 is 10. And now this is going to be a remainder because there's no more x that we can take out. So our final answer is going to be 2x squared plus 3x plus 15 plus 10 over the x minus 5. Are there any questions? Okay. think my next slide, I'm going to run out of space. So I'm going to see if I can insert a slide on while I've never tried to insert a slide while I'm still. Oh, it works. Cool. I didn't know that I can insert while in presentation mode. Cool, cool. Okay. This one's going to be long. This one's definitely going to take more than one slide's worth of space because it's got a lot going on here. So some of these can take a whole page depending on how many things you have going on. So we've got negative 48 minus 28x plus 20x squared plus 17x to the third plus 3x to the fourth. So we should have 5 terms. Our highest exponent's 4, so we want to have 5 things written down. And then we're dividing that by x plus 3. So I'm going to just draw my line at about the halfway point. Now when I write this, we always want to write our division from the highest term to the lowest. It's just like when you write numbers, you have like the biggest place going first, like the thousands place number is going to be written before you write the 100th place. So I need to basically rearrange this order, and I'm thinking even with that line I may not have enough room. So I'm going to draw the line after I rearrange. I may not even have room for that line, and I might just have to do it off to the side because this is taking up the whole slide here. So I have to put the 3x to the fourth first. Then I have 17x cubed, then the 20x squared, then the minus 28x, then the minus 48. So what I think I might do is just on the second slide put my work, my kind of the side work, and I'll just do that on the second slide and switch between. So I'm going to be taking the first term out of each of these. So I'm going to be taking my 3x to the fourth and dividing it by x. So I'm going to just do that on the next slide here. 3x to the fourth divided by x. So that's basically removing an x, and I get 3x cubed. So I'm going to get 3x cubed up here on top. And now I need to multiply that 3x cubed by x plus 3. So I'm going to actually just x cubed times x plus 3. I'm going to just put these all in the same row since I have the space. So 3x cubed times x is 3x to the fourth. And then 3x cubed times 3 is 9x cubed. So I have 3x to the fourth plus 9x cubed. 3x to the fourth plus 9x cubed. So I write that underneath. And we draw the line and we change the signs. And then we combine. 3x to the fourth minus 3x to the fourth is 0. 17x cubed minus 9x cubed gives me 8x cubed. And then I'm going to drop down my 20x squared. I'm going to repeat the process with 8x cubed. So next slide, I'm going to have 8x cubed. I'm dividing that by x. And that gives me 8x squared. So I'm going to go ahead and write that on top. Then I need to multiply that 8x squared by the x plus 3. So 8x squared times x gives me 8x cubed. 8x squared times 3 is 24x squared. So I have 8x cubed plus 24x squared. 8x cubed plus 24x squared. I'm going to write that underneath. And then I draw my line, change the signs, and combine. 8x cubed minus 8x cubed is 0. 20x squared minus 24x squared is negative 4x squared. And then I'm going to drop down minus 28x. You can see as we go through the process, we're basically doing the same thing over and over and over again. And this is why it's called an algorithm. This is something that if you had to write a program, it'd be really easy to program this because you're just doing the same thing over and over again. You're just looking at a different expression each time. So now I'm going to take the minus 4x squared and I'm going to divide that by the x. So minus 4x squared divided by x gives me a negative 4x. So I'm going to write minus 4x on top. Then I take that negative 4x and multiply by x plus. So negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. So negative 4x minus 12x. Negative 4x squared minus 12x. X squared minus 12x. It's a lot easier when you don't have to switch between slides. So draw the line, change the signs, and then combine. Negative 4x squared plus 4x squared is 0. Negative 28x plus 12x gives me negative 16x. And then I need to drop down negative 48. And I'm running out of room here. So this will be interesting. So now we're going to look at the negative 16. We keep going until we basically don't have any variables left. So I have the negative 16, a negative 16x that I'm dividing by x. So negative 16x over x. Those cancel. That gives me negative 16. So I'm going to write negative 16 up there on top. Then I take that negative 16 and multiply it by the x plus 3. So negative 16 times x is negative 16x. Negative 16 times 3 is negative 48. So negative 16x minus 48. I'm going to try to smush it in there. So then you draw the line and you change the signs and you combine. Negative 16x plus 16x is 0. Negative 48 plus 48 is 0. So we've got the whole thing canceled. And this means that we have no remainder at all because basically the whole thing canceled out. So there's no remainder that's divided evenly. And when that happens, then whatever you have written up in top, because you don't have to worry about a fraction or anything, that is your answer. So our answer is 3x cubed plus 8x squared minus 4x minus 16. So that divided out evenly. And what that means is if you can divide it and you get no remainder, that basically tells you that you were able to factor that out. So we say that this is something that is factorable, and we could factor that out. Now, we don't know how to factor something that's x to the 4th, because we've only learned how to factor things that have a greatest common factor or are quadratic. But that's why we have this process, so you can factor things that are bigger. So we just found a factor, and you could potentially repeat this process over and over again to find each thing that divides into it evenly. But we usually use it with synthetic division instead because it's a quicker process. There. Any questions on this example? Okay, I'm going to have one more example. Oops, I put my blank slide in the wrong spot. Let me rearrange that. Why did that go there? Let's see if I can get it in the right order now. Okay. Rearrange it. Now I have my blank slide in the right spot. Okay. This is going to be another long one, and this one's slightly different because now we're dividing by an x squared instead of an x. So we've got x to the fifth minus 2x to the fourth plus x cubed minus 8x. So we're missing, you want to note that we are missing in here an x squared term. So you're going to have to put in a placeholder of 0x squared. Then we have minus 8x plus 18. So I'm going to write long division. And I need to make sure that I'm counting down with all of my exponents. And then I'm dividing this by x squared minus 3. Now you don't have to add a placeholder for what you're dividing by, only for what's inside the division symbol. So I don't need a placeholder for the x squared minus 3. I don't have to add a 0x. So process is exactly the same. I'm going to take that x to the fifth and divide it by x squared. So I'm going to do that on my next slide here. X to the fifth or x squared. So in this case, when we're subtracting these or dividing these, you subtract the exponents. 5 minus 2 is 3. So I get x cubed. So I'm going to put x cubed on top. And then I'm going to take that x cubed and multiply it by the x squared minus 3. So x squared times x cubed times x squared is x. Add the exponent, so that's going to give you x to the fifth. Then x cubed times negative 3 is negative 3x cubed. So I get x to the fifth minus 3x cubed. X to the fifth. Now I have to write that minus 3x cubed underneath the like term. So this one's a little different because I had to kind of write it differently. So I draw my line. I'm going to change the signs and then combine. So x to the fifth minus x to the fifth is 0. And then I look at my x cubed. 1 plus 3 is 4. Now, when I drop things down, I need to drop down that minus 2x to the fourth that I didn't do anything with. So that is what's going to be dropped down. So because I ended up skipping around, I ended up with this little hole, and that's what's going to have to be dropped down. So now I'm going to look at the negative 2x to the fourth. So negative 2x to the fourth over that x squared. We get a negative 2, and then 4 minus 2 is 2, so the exponent is 2. So I have negative 2x squared. Negative 2x squared, that gets written up there. And then I need to multiply that by x squared minus 3. So negative 2x squared is multiplied by x squared minus 3. So negative 2x squared times x squared is negative 2. You add the exponents, so that's x to the 4th. Then negative 2x times negative 3 is a positive 6x squared. So I have a negative 2x to the 4th plus 6x squared. Negative 2x to the 4th plus 6x squared. So now you see that I have a whole kind of here again. I need to take my 0x squared and I need to actually kind of drop that down so I have something to add it to. So I have to actually end up dropping down more than one thing right here so that I can add everything together. So I draw my line, change the signs, and then combine. And if these holes are getting confusing, you can even add in plus 0 things for placeholders there so that you can add those together. So let me draw that arrow there. Negative 2x to the 4th plus 2x to the 4th is 0. 4x cubed plus 0x cubed is 4x cubed. 0x squared minus 6x squared is 6x squared. So I already kind of dropped something down in order to do this addition, so I didn't have to drop anything down again. If I need to, I will. And now we're going to look at the 4x cubed. So this kind of problem is weird because of the x squared, so you're kind of creating holes and you're kind of alternating what you're doing here. It's an interesting kind of problem. So I'm going to take 4x cubed and divide it by x squared. So that leaves me 4. 3 minus 2 is 1, so I'm left with a single x. So I'm going to write plus 4x as my next term. Then I'm going to take that 4x and multiply it by the x squared minus 3. So 4x times x squared is 4x cubed. 4x times negative 3 is negative 12x. So 4x cubed minus 12x gets written underneath here. 4x cubed minus 12x. So I have to then, because I have this extra space, I need to fill it in. So I'm going to have to drop down my minus 8x here so I have something to add it to. And then if it helps, you can put a 0x squared here to kind of fill in your missing spot. We're going to draw the line, change the signs, and then combine. 4x cubed minus 4x cubed is 0. Negative 6x squared minus 0x squared, it's still negative 6x squared. Negative 8x plus 12x is plus 4x. So now I keep going because I still have an x squared that I can divide by an x squared. And this should be my last step because now I've got an x squared and x squared. As I do my division, I'm going to end up with an x, and then I can't divide that by an x squared. So this is going to be the last step. And unfortunately, I'm going to kind of have to, normally I would do these all in the same line, but because I'm running out of room here, I'm going to have to line it up differently. and I'm going to automatically drop down my plus 18. I'd normally be dropping it down right there. I'm kind of doing it on the right because I don't have any more room here. But I'm still going to be taking that negative 6x squared and dividing it by the x squared. So those x squareds cancel, and I'm left with the number. And that's your indication. Once you get to a part where you're left with just a number, that's indicating that's going to be your last step. So that gives me minus 6 up there. So then I take that minus 6, multiply it by the x squared minus 3. So negative 6 times x squared is negative 6x squared. Negative 6 times negative 3 is positive 18. So I have negative 6x squared plus 18. Negative 6x squared plus 18. So we draw the line, change signs, and if it helps, I can put a 0 in there, and then combine. Negative 6x squared plus 6x squared is 0. 4x plus 0x is 4x. 18 minus 18 is 0. So that 4x ends up being our remainder. This was our last step, so this is our remainder. So our answer is x cubed minus 2x squared plus 4x minus 6 plus, and then my remainder is 4x, so that's going on top, and then we divide it by x squared minus 3, so that's underneath. So that is how you write your answer. So some of these get pretty lengthy, but we try not to give you too many that are long like this one. At least if you have a sheet of paper, you should have plenty of room. You're not stuck to a slide like I am.